We are fortunate this morning to have Dylan Foster, who's been part of our community for about 10 years. He graduated from Goldwater High School and now is a student at Phoenix College, majoring in forensic biology. His talk today is titled Ethics, Morals, Politics, Stem Cells. Welcome, Dylan.
Can everybody hear me okay?
Yeah.
So good?
Lose the
Alright. Well, hello everybody. It's so good to see so many of you decided to join us on this mild summer morning. Most of you already know me, the son of Fanny and Joel. I've been coming to West Valley UU now for over 10 years. And when Dorothy came to me and asked if I'd do a sermon, I kind of knew what to expect and how to go about making my speech, but picking the topic was ultimately the hard part for me. I wanted to pick a subject that I found interesting and would provide the essence of a thought-provoking sermon, a subject that could be related back to Unitarian Universalist principles. Eventually I decided on the much-debated issue of stem cell research. There are a few reasons why I decided on this specific topic. One is because during my first year of college, in the prerequisite biology and English classes, and even before that, in high school, a couple of major assignments pertained directly to the subject of stem cell research, which in turn allowed me to study the in-depth inner workings, advantages, disadvantages, moral dilemmas, and arguments regarding the various types of stem cell research. And since I'm a biology undergraduate, I feel it strikes very close to home for me. Stem cell research is a very misunderstood scientific practice that many of American citizens are actually quite misinformed about still. And while I may not have any actual credentials in this field of work yet, the research I've done with regard to this subject has been taken mostly from noteworthy, peer-reviewed articles and journals that have been published already. Also, I will try not to make the sermon sound like a biology lecture with the myriad of nomenclature and technicalities, so bear with me if I do. Another reason why I chose this topic is because I feel that it relates back to at least two major Unitarian Universalist principles: the inherent worth and dignity of every person, and the free and responsible search for truth and meaning. Now, I would like to make clear that the purpose of the sermon is simply to educate, and not to belittle or trample on any personal viewpoints or opinions. I am here merely to provide information that you as individuals can then make a rational decision about, which is one of the reasons why I like the Unitarian Universalist Church. All of you can think for yourselves, which unfortunately is not a skill that all people have. First off, what is a stem cell? What are the benefits of stem cells? Why all the discussion over these certain types of cells? Well, to put it simply, stem cells are cells that are found in multicellular organisms that can divide through the process of mitosis, can differentiate into numerous different types of cells, and then self-renew to produce more stem cells. For those who are unaware of the process of mitosis, or simply forgotten from high school, it is when a cell duplicates its DNA and then divides into two daughter cells that are more or less genetically identical of that mother cell. The importance of this is because in humans, mitosis is mainly undertaken when the body is in need of cellular replacement or repair, such as with your skin cells or red blood cells, and during the growth and developing stages of your body. The main reason why these stem cells are so astounding and unique is because of their ability to become almost any specialized kind of cell in the human body. Scientists call this ability totipotency or pluripotency, depending on the type of stem cell. Now, I would like to highlight and describe the similarities and differences between the two major classifications of stem cells: adult somatic and embryonic. First, somatic. Somatic means of the body. So simply put, adult somatic stem cells are stem cells that are found throughout the body after development and can multiply by cell division indefinitely. Embryonic stem cells, however, are taken from the cells of a blastocyst, or an early human embryo. Embryos reach the blastocyst phase 4 to 5 days after fertilization and only consist of 50 to 150 cells. Unfortunately, the current methods of extracting blastocyst cells does in fact kill the embryo, and is the main cause of controversy with regard to stem cells. These two different types of stem cells do have their differences when it comes to applied practical use. Embryonic stem cells have the ability to differentiate into 220 different types of cells in the human body, which is most of them, while adult somatic cells are significantly less multifaceted. This versatility in embryonic stem cells is one of the reasons proponents vie for the continued application and research in this field. There are a few disadvantages amid stem cells, though. One being donor-host cell rejection of the injected stem cells. Much like a donor organ can be rejected by a new host, so too can the tissues formed by these stem cells. This problem can be reduced, however, by using different cell lineages taken from people of different genetic backgrounds and pairing the most closely related donor cells to the new host. Another speculation regarding stem cells is the potential for cancer cells to develop out of the mass of stem cells. However, this has not been observed in trials so far, and is only a potentiality at the moment. Scientists have already begun to address this, though, by allowing the cells to become specialized into a certain type of cell before re-injecting them into the host. As for the advantages, there have been numerous instances where stem cells, both embryonic and adult somatics, have provided breakthroughs in the field of biomedical science. One example of the application of embryonic stem cells was an experiment conducted by scientists at the Texas Biomedical Research Institute, who demonstrated that baboon embryonic stem cells can be programmed to completely restore a severely damaged artery. The researchers completely removed cells that line the inside surface of a segment of an artery, and then put stem cells that had been derived from that host to replace that small segment. Amazingly, only after 14 days, the inside of the artery had been perfectly restored to its complex natural state. It went from essentially a non-functioning tube to a complete, fully functioning artery. Yet another reason why embryonic stem cells are remarkable can be derived from an experiment a team of researchers in Scotland developed that makes use of 3D printing in conjunction with stem cells. They used the 3D printing technique to arrange human embryonic stem cells in layers in order to form three-dimensional structures for the very first time. The major implication of this experiment is that scientists will soon be able to construct working three-dimensional tissues and organs that can differentiate from the cells of an afflicted individual, thereby eliminating the need for a donor and resolving the issue of immunorejection from the constructed organ. As a result of this extraordinary versatility, stem cells can be used to grow nerve cells to repair spinal injuries and restore functions to paralyzed limbs, to grow heart muscle cells to replace useless scar tissue after a heart attack, to make brain cells that would secrete dopamine for the treatment of and control of Parkinson's disease, to grow cells that make insulin, creating a lifelong treatment for diabetes, to grow bone marrow to replace blood-forming organs damaged by disease or radiation, to make blood cells genetically altered to resist specific disease such as HIV, and there are potentially many more possibilities. The stance that the government has taken towards stem cells, however, has also been convoluted by the American public. No federal law ever did ban stem cell research in the United States, but only placed restrictions on funding and its use under Congress's power to spend. In February 2001, George W. Bush requested a review of the National Institute of Health's guidelines, and after a policy discussion within his circle of supporters, implemented a policy in August of that year to limit the number of embryonic stem cell lines that could be used for research. In April 2004, 206 members of Congress, including many moderate Republicans, signed a letter urging President Bush to expand federal funding of embryonic stem cell research beyond what Bush had already supported. In May 2005, the House of Representatives voted 238 to 194 to loosen the limitations on federal-funded embryonic stem cell research by allowing government-funded research on surplus frozen embryos from in vitro fertilization clinics to be used for stem cell research with the permission of the donors, despite Bush's promise to veto if passed. On July 29, 2005, Senate Majority Leader William H. Frist announced that he too favored loosening restrictions on federal funding of embryonic stem cell research. On July 18, 2006, the Senate passed 3 different bills concerning stem cell research. The Senate passed the first bill, 63 to 37, which would have made it legal for the federal government to spend money on embryonic stem cell research that uses embryos left over from in vitro fertilization procedures. On July 19, 2006, President Bush vetoed this bill. The second bill makes it illegal to create, grow, and abort fetuses for research purposes. The third bill would encourage research that would isolate pluripotent, i.e. embryonic-like, stem cells without the destruction of human embryos. The National Institutes of Health has hundreds of funding opportunities for researchers interested in human embryonic stem cells. In 2005, the NIH funded $607 million worth of stem cell research, of which $39 million were specifically used for embryonic stem cells. During Bush's second term, in July 2006, he used his first presidential veto on the Stem Cell Research Enhancement Act. The Stem Cell Research Enhancement Act was the name of 2 similar bills, and both were vetoed by President George W. Bush and were not enacted into law. New Jersey Congressman Chris Smith wrote a Stem Cell Therapeutic and Research Act in 2005, which was signed into law by President Bush. It provided $265 million for adult stem cell therapy, umbilical cord blood, bone marrow treatment, and authorized $79 million for the collection of cord blood stem cells. By executive order on March 9, 2009, President Barack Obama removed certain restrictions on federal funding for research involving new lines of human embryonic stem cells. Prior to President Obama's executive order, federal funding was limited to non-embryonic stem cell research and embryonic stem cell research based upon embryonic stem cell lines in existence prior to August 9, 2001. Federal funding originated from current appropriations to the Department of Health and Human Services under the Omnibus Appropriations Act of 2009. And it remains prohibited under the Dickey Amendment for the creation of human embryo research purposes. Research in which a human embryo or embryos are destroyed, discarded, or knowingly subjected to risk of injury or death greater than that allowed for researchers on fetuses in utero. In his speech before signing the executive order, Mr. Obama noted the following: "Today, with the executive order I am about to sign, we will bring the change that so many scientists and researchers, doctors and innovators, patients and loved ones have so hoped for and fought for these past 8 years. We will lift the ban on federal funding for promising embryonic stem cell research. We will vigorously support scientists who pursue this research, and we will aim for America to lead the world in the discovery it one day may yield." Of course, the issue I haven't talked about yet is the moral dilemma regarding stem cell research. The major problem most people think of when they hear stem cells is with respect to embryonic stem cells and the killing of the embryo. Much opposition to the research comes from the belief that human life begins at the embryo stage, which would mean murder occurs every time the cells of a blastocyst are extracted from stem cells. Furthermore, a danger also lies in the exploitation of women by enticing them to relinquish an embryo by coercion. This could also in turn become the start of illegal trafficking of embryos for the use of stem cells. One such solution that has been developed, though, in response to the problem of killing an early human being is the use of parthenogenesis. In parthenogenesis, a developing oocyte, or unfertilized early egg, is stimulated to begin to develop as if it had been fertilized. In essence, the oocyte cannot complete gestation nor be born as a living offspring, technically speaking. But embryonic stem cells can still be collected using this method. Now, the argument regarding the coercion of women is a valid one that does not lend itself to an easy solution. Keeping women educated and informed about the processes behind embryonic stem cells and their derivation would help lessen the chance of illicit manipulation. Also, producing federal or state rules and regulations regarding embryo acquisition would ensure legal consent for research. Just as there are regulations for pharmaceutical drugs, there can be regulations for embryonic stem cells. And as I said earlier, I believe that the subject of stem cell research is pertinent to Unitarian Universalism in the sense that the principles regarding the inherent worth and dignity of every person and a free and responsible search for truth and meaning are applicable. Since the sentience of a human being is at the moment in time not collectively agreed upon, it is important to at least acknowledge the opinion of the opposition in that human life may or may not begin at the embryo stage. If an embryo is indeed a person, then it is indeed indignant and immoral to extract stem cells using such harmful methods. But if the opposite holds true, then it is at least within a UU to respect the inherent worth and dignity of that person's opinion, even if they disagree. Because each and every one of us are searching for the truth and meaning of life in our own ways, and it is beholden to us to advance our knowledge of science and stem cell research in a responsible manner that accounts for most, if not all, of the detriments and variables that may form as a result. Thank you for your time.
Okay, please stand as you're willing and able and join us in singing our closing hymn, number 134, Our World is One World.